gonna wait like 3 more minutes before we start.
Okay, so you guys want to come in here and we can just say hello before we get started? Okay, so hello everybody. We're going to get started in a few minutes here. Just going to wait for everybody to get in. I think the audio's on this. Could we turn that up? No, it's fine. Okay, yeah, so just going to give everybody a chance to get here. Maybe start around 2:02 just to have a little bit of a grace period. Let us know in the chat if the audio is cutting out or if you have any questions during the stream or anything like that. We're going to have it open over here so that we can respond to you guys. There's a very slight delay we're working with, but it's not more than 10 or 15 seconds, so it shouldn't pose much of an issue for any questions you guys have. You ready to go? Feel free to say hi, chat, those PogChamp emojis, and the like. I don't know if YouTube has the Twitch emotes. I don't think they do. We could have custom Twitch emotes. There we go.
Johnny says hi. Hi, Johnny.
There we go. Oh, there's a slight lag here. Interesting. Okay, great. So just give it another minute and then we will get started. Okay, so you guys want to get started?
Sure.
Yeah. Okay, so without further ado, thank you very much for joining us today. And those of you who signed up through Eventbrite, you know what you're in for. Those of you who have found us randomly from the YouTube Live page somehow, we are going to be talking about user experience evaluation in games. More specifically, we're going to be talking about automating the process of user experience evaluation in games and how kind of AI testing approaches can help the game design process. And we're going to be showing you a demo of a framework that we're working on for automated testing in games as well. Okay, so just a little bit about us. I'm Samantha Stalkey. I'm a graduate student and a sessional lecturer at Ontario Tech University in Ontario, Canada. And my kind of master's research and research in general is about games user research and more specifically using artificial intelligence to help empower games user researchers.
Hello, my name is Atia Nova. I am an undergraduate student at Ontario Tech University and I'm studying game development. I work as a student researcher and my research interest involves AI.
And hi everyone, I'm Pejman. I'm a faculty member here. And I'm kind of supervising different projects. This one is one of them. Thanks again for joining us. I hope you find this session useful.
Okay, so let's hop right in. Just a quick intro to what we're going to be doing today. We're going to be talking a little bit about automated game testing in general, going over some of the other kind of projects that have been done in this field just to establish the context for our work. We're going to do an overview of the system we're working on right now, and we're going to give you a bit of a demo of kind of what we have so far, how it can be used, and how you can apply it in your own projects. And then at the end, we're going to have a little bit of time for Q&A. Anyone who wants to post kind of questions in the chat, follow up, talk about, you know, if you want to stick around afterwards and talk about collaborating with the university, we're open to that as well. So
Just to start off, playtesting, the act of using human testers to play through a game, is a really informative process. It can help designers better understand the user experience of their game, and it has many benefits. Designers can become more aware of things such as whether or not their game is too imbalanced, whether the tutorialization is done correctly, and whether players enjoy the experience that the game offers. Playtesting can potentially result in designers finding and improving upon problem areas before a game is released, potentially resulting in a better product. Unfortunately, playtesting is also an expensive and time-consuming process. In order to run tests, one would have to recruit participants that fit into the target demographic, set aside adequate time to run and analyze the tests, invest in the necessary equipment, and so on and so forth. All of this can become a logistical nightmare, and it can put a strain on studios that don't have access to all of these resources. A possible solution for all of this is automated game testing. This could involve rule-based evaluation, which is the use of AI systems to run tasks such as checking the playability of a level based on its geometry. It can also involve using bots to play through a level in order to gain insight as to how players respond to the content. So using AI can help mitigate resource costs associated with hiring testers. Not only does it eliminate the need to organize and screen them, AI can also potentially complete tests at a faster rate than humans, and it doesn't require additional equipment or lab space. Since AI can speed up the process, designers can get results at a faster rate, allowing them to iterate on the design of their game quicker. Overall, it makes playtesting a much more accessible experience for studios that are normally not able to partake in it. And these are just some of the benefits. There are many other applications as well.
Okay, so there's a couple different categories of game testing, as probably everyone here is familiar with, and AI actually has the potential to help us in multiple different areas. So we're going to look at kind of two of those main areas today, kind of a very broad strokes approach to categorizing the types of tests that are done. First, the idea of QA testing. So really quickly, everyone knows QA testing is kind of about finding bugs with a game. It's not about analyzing the human experience or kind of figuring out whether your players are having fun. It's just, is the game kind of working as intended from a technical perspective? So some of the precedent in the area of QA testing, one of the projects that was done last year actually is called Cicero. We have papers for all of these projects from other researchers. If you're interested in accessing those papers or finding out more about their work, stick around at the end and feel free to ask us. So basically with Cicero, what happens is that there are these AI agents that are designed to work with games spelt out in a very specific video game description language framework. And what the researchers found with this was that humans observing bots play through a game were actually more efficient at finding bugs than humans that were playing through that game themselves. So the idea of AI just being kind of more efficient at testing through all the potential ways that you could move through a level or kind of pushing the system to its limits, if you pair that with a human observer, it's more effective than just letting a human run around in a game by themselves. So kind of an interesting and sort of provocative take on how you can kind of optimize that bug testing process. Another project that was done later was similar in the same description framework. It was using reinforcement learning agents that would kind of learn from human behaviors to find out what human players would sort of do in a level and to try and use that to completely automate the process of finding bugs, so not even requiring a human observer. And what was found in this case was that the AI agents actually approached human levels of proficiency in finding bugs, hitting around 80 to 100% of the bugs that were intentionally introduced in each game. So just the idea here is that we've kind of reached the point where even really simple AI agents and bots are capable of achieving near human performance in bug testing in really simple game environments. So on to the second category that we'll be looking at, which is kind of more of what we're concerned with today, playtesting.
Yep. So when testing with humans, it's possible to evaluate different aspects of the game, such as its difficulty, its playability, and the experience that the game offers. So these tests can help answer questions such as whether or not the levels are playable within the context of the game, whether or not players enjoy those experiences, and whether or not certain aspects of the design should be adjusted to offer a better player experience. The following research showcases how these questions can also be answered with AI.
We're hearing that the mic is a little bit quiet, so we're just going to move in a little bit. Maybe speak up slightly louder.
Okay.
Let us know if you're still having trouble hearing us, Josh. We just adjusted our setup here. Okay.
So ROPA-sum is a level generator that, through the use of evolutionary algorithms, generates cut-the-rope levels. After the levels get generated, Rule-based and physics-based search engines confirm how playable these levels are by building state trees and by performing a depth-first traversal of those trees. And a level is deemed playable if there is essentially a sequence of actions that solves that level. And this is an example of procedural content generation without the need for validation from humans. So for The Sims Mobile, these researchers created agents that would use the A-star algorithm to evaluate what actions they should take within the game. This approach allowed the researchers to test the balance of the game while only having to worry about modifying the interaction paths and the heuristics of the agents in order for them to achieve different in-game goals. This, along with separating the base mechanics of the game into a separate system, allowed the researchers to get results within a matter of minutes with AI, whereas it would have taken days with human testers. And lastly, for testing purposes, these researchers created AI procedural personas that used a variation of Monte Carlo tree search. And these personas would imitate different playstyles by prioritizing interactions that fit each style. So, for example, for a dungeon crawler, a monster killer would focus on killing as many monsters as possible, and so on and so forth. So, levels would get evaluated based on key interaction metrics, such as how much each persona has to do within them.
Okay, so we're going to move on now to talk about our framework before we kind of show you a demo of what we've been working on and kind of some applications of how you could use this sort of approach in your own work. So we're just going to talk a little bit about kind of our motivation for creating the system and how it works before we jump into the demo. So one of the really key kind of pain points that, Pejman and I were looking at when we originally came up with the idea for this system was the fact that recruitment can be a pretty big pain, as everyone here is probably familiar with. So, when you're testing your game, you really want to make sure you're getting people from your target audience. It can really be tough to get a population of players on short notice that have the experience you want, that have the player profile you want. They're fans of the genre, or maybe they're new to the genre, conversely. It can be just really difficult to get these players on short notice. So what if you could kind of, mimic the behavior of those players at a high level so that you could test your ideas early on, get a course idea of what players would do without actually having to go out there and find 50 people that match your target player profile. We found when we were kind of looking up research, like the last project that Atiya presented there about automated game testing, there was a lack of solutions that were at least trying to be game agnostic, that worked maybe in different genres or even in different projects. It's kind of a lot of proprietary commercial solutions out there, solutions that are meant to work with one game or one very specific type of game, and so forth. We also really wanted to create something that was open source and accessible to indies. Again, motivated by the fact that there were a lot of closed source proprietary commercial solutions being experimented with, we thought, well, who's working on one that'll be available for everybody, that indie developers who can barely afford to run a couple of playtests as it is could maybe use to get an indication of how people would act in their games. We also wanted to make something that would integrate with an existing workflow rather than requiring you to have a special build of your game or instrument your code really heavily or anything like that. So we wanted to create something that would be kind of easier to work with. So our precedent for this work, the kind of way that we approached it, was to take an expert systems approach. We're looking at the idea of using a machine learning one kind of later on, once we have maybe some more data from human testers, once we can expand the system a bit. But our work's really fundamentally based in kind of these existing theories of player psychology and player typology. So everyone here's probably familiar with this. I'll go over it pretty quickly, but player typology is basically the idea of classifying player behavior based on the characteristics of that behavior. So the most famous example of this is maybe Richard Bartle's types in 1996, killers, explorers, socializers, and achievers. The idea that different types of people with different motivations will have different behavior in games which reflects those motivations. Today, the focus is on kind of the idea of intrinsic motivation, why people play from a psychological perspective. It's kind of that marriage of looking at patterns of actions in games and patterns of motivations for your players. Why would somebody be compelled to fight a lot of enemies versus, explore every corner of the map or pick up a lot of potions or whatever your differentiating factor is for different types of players. We're really seeking to answer the question, why do players do what they do? With the idea being that if we can answer this question, then we can reproduce that behavior with bots or a machine learning system or what have you. So the way our system works is that we have these little agents that are, again, driven by an expert system. This isn't a machine learning system. Just clarifying that again, just because there are a lot of machine learning approaches out there today. I know when people say AI, kind of our minds jump to machine learning these days. But essentially what the agents do is they have little mimics of different parts of kind of player logic, if you want to call it that. So information comes in from the game world. It goes into a little system that mimics players' perception. There's a little camera that mimics what the player would see in game. You know, it kind of uses the underlying physics engine to determine what's visible and such. That information gets conveyed to a representation of memory, which kind of based on existing work in cognitive research and human psychology, it looks at, you know, enforcing a cap on an agent's short-term memory. So you can't keep track of absolutely everything in the game at once. An agent isn't going to remember the exact location of an object. It's going to approximate it much the same way that a human would. And that kind of information based on what the agent can see and what it remembers from what it's seen in the past gets fed into a goal selection algorithm, which is based on a number of heuristics, which we'll go over in a second. We'll kind of show you some of those heuristics during the demo. And then after the agent selects what it's going to do in the game based on that, it takes action, which again, we're going to look at in the demo in a moment. So you, as the designer, you know, you're a little less concerned maybe with the individual steps of how this process works, and you're wondering how you can use a framework like this for testing. Well, in the demo that we're going to be showing you, there's a few different steps that you take to just run an AI test of your game and kind of approximate what players of a certain motivation or a certain player type would do. So your first step is to basically mark up the level, tell the agents what entities are in your game and where. None of this requires instrumenting your code in any way. This is all a layer that's on top that's kind of in the Unity editor, which we'll show off in a second. You bake a navigation mesh. Anyone that's ever designed a level is going to be super familiar with this. Basically, the nav mesh is what tells your game AI where to go. It's what can interface with maybe your control systems to tell you what terrain is navigable for your player. And then after that's done, you set up your AI agents, you specify what their profiles are, you run your test, and you can record logs of where they go before you can visualize that with the inbuilt visualization tool. So this is kind of a similar workflow that you could probably expect with any automated testing tool, but we're going to go over this a little more in depth with our tool in a few moments. So yeah, without further ado, let's just move on to a demo of the framework. So we're actually building this framework for Unity, and the impetus for that decision was just the idea that Unity is an engine that gets used a lot by indies. It's freely available. It's something a lot of people are familiar with. This is obviously a solution that we want to be able to port to multiple different creation environments eventually, but we thought to make it open source, to make it accessible to independent developers that are already working with limited budgets, that Unity would be kind of a good first choice. So the purpose of the framework, the kind of questions that you'll want to answer with it are something like, are players following your golden path? We're looking at where players are going to go. These little agents, they navigate through the level. They give you an idea of how players are going to navigate. Are there dead zones in a given level? That's another question you could ask. You know, if you're creating a little world, are there going to be places where players aren't really going because there's nothing interesting for your target audience there? Are there going to be zones where they're kind of concentrated because that's just where they're navigating in the level, and maybe you can put some extra things there for them? You can also ask about things like what's, you know, the rate of engagement with different objectives in the level. If you're a mission designer for an action game and you've got this big open map, you've got some main objectives that are mandatory, you've got a bunch of little side objectives peppered throughout, you want to know, are players engaging with that side content that you're putting in the effort to put in your game? Are players actually getting something out of it? Or is that just kind of wasted labor that's not really being engaged with? That's another thing that you could kind of use this tool to answer. I should give a cautionary note. Since we're trying to make this tool as game agnostic as possible, we're just looking at navigation in the 3D environment. We're not looking at simulating combat or anything like that. There have been some projects in the kind of games research community that have looked at simulating more specific aspects of gameplay in individual games. We're kind of going in the opposite direction in that we want to be able to port our solution to many different games, so we're just looking at simulating navigation. So the requirements to basically use this framework in its current state, it is built to work with Unity. In the future, we'd be looking at porting it to other tools, but right now it is Unity only. You need to have Unity's navigation mesh baked into your level, so anyone who's familiar with Unity has probably seen this before. The tool interfaces with all of Unity's existing components to minimize instrumentation of the actual game code that you're working with. So that's kind of the reasoning for that. And the current iteration is kind of mostly built on the idea that your world is kind of open, planar, outdoors, or in a simple sort of structure. There's not a lot of support for verticality at the moment. So if you're making a game set in a skyscraper with lots of complicated kind of indoor geometry and lots of layers, wait for a future version of the framework before you kind of import it into your project. Our goal here is really simple navigation if you're using it out of the box, though being open source, again, it is modifiable to the needs of specific projects. And kind of the idea here is that it's ready to go just by dragging in a couple of prefabs. So all you really need, which we'll kind of show in a different demo scene in a moment, is this little manager component that kind of orchestrates markup for the agents so they know what's available in the level, and then the little agents that run around and predict where players would go. So assuming that you import these into your scenes, that's it. You don't need to instrument your code in any way. You don't need to modify your level geometry or kind of make any special rules for the agents to move around. It all interfaces with Unity's existing physics, and it's all just kind of built on that. So I'm just going to open a little demo scene here, and we'll just kind of go over the different steps of using the framework and kind of show you what these agents look live and kind of what their little brains can be like. So the first step when you're working with the framework is this kind of markup stage. So what that is that you'll see these little icons are overlain on the world. We have this little panel on the right here that shows what they are. This is basically a sort of drag and drop thing. I'll just delete these so you can kind of see the process, where you just kind of define what types of objects there are in your level for players to interact with. So in this case, the level that we have here is kind of maybe a simple little RPG where there's little characters to interact with, there's different enemies that you could fight, there's different things to collect, maybe there's little traps in the world or little houses and kind of points of interest that players would go to. And this categorization that we have here is kind of based on a review of the existing game design literature. Again, it's designed to be as agnostic as possible, but the idea is that as the designer, you kind of go through and mark up which objects in your level are interactive. So in this case, these little bags and crystals here are meant to be collectibles, so I'm just going to take this little collectible brush, and then I'm going to tag these objects as being collectibles. And that's it. Kind of once you've gone through, I've already marked up the rest of this level, you know, cooking show style, we had this prepared before. You can kind of see where everything is in the level and kind of where players need to go. So the idea with this level is that you can see these sort of mandatory objectives are these little crystals that are scattered throughout, and then kind of once players hit up those crystals, they can go to this little tomb area, which is marked as the final goal. And these are the kind of default entity types that we have available for markup, but again, the system is customizable and you could kind of add new types relatively painlessly in code to suit the type of game you're working with, though they are designed to be as generic as possible. So kind of what you've finished, once you finish that markup stage, you can kind of move on to customizing your agents to reflect your target audience and kind of the type of player that you'd want to play test with. So you can run these agents one at a time. We also have facilities for kind of batching them, running a bunch of tests once at an accelerated timescale, just so that we're delivering on that promise of kind of making testing as painless and as resource not intensive as possible. But if you're running the agents one by one, you can also just have a look here at what their personality customization looks like. So the idea here is that agents basically have 7 little values that determine how they're going to behave. And these are based on existing models of player typology. If you're familiar with the typology literature, you've probably seen some of them before. So the first one is the idea of game experience. So basically how many games they've played in the past. Everything's just on this normalized little slider. So if you want a novice, you pop that down to 0. If you want someone who's a super veteran, you plunk it up to 1. We'll maybe put this guy towards the upper middle. And what that kind of affects is how good the agent is at playing. Basically, you know, someone who's more experienced with games, they're going to be able to kind of remember more objects. They're going to be able to know where things are a bit better because they're kind of used to navigating in game worlds and that sort of thing. The other metrics, curiosity, this is kind of based on Bartle's explorer archetype. A curious agent is going to be more compelled to see absolutely everything in the level before they move on to the final goal that kind of marks the end of the experience. They're going to be compelled to talk to NPCs and kind of look at buildings or things that are kind of marked as landmarks to the agent. They're not necessarily going to be obsessed with collecting absolutely everything in the level, but they're going to want to see all parts of the level. Achievement is kind of similar to Bartle's achiever archetype, just the idea that they'd want to collect everything that's marked as a collectible. They'd want to hit up every mandatory and every optional objective. They just kind of want to, maximize their score. A completionist is kind of a little bit of a mix of the both of the previous two kind of criteria there. So the completionist player, I know I'm one myself. I think a lot of people here might be completionists as well. If you got into game design, chances are that you have a little bit of that streak in you. This is the idea that you would want to interact with everything in the level. You don't just want to see it, you want to fight every enemy, you want to pick up every potion, you want to grab every collectible, you want to complete absolutely every objective, and you want to 100% the level before you even consider leaving. So that's kind of what the completionist type agent will do. So let's ratchet up that and achievement so we get someone that's kind of really hungry to collect everything in the level. Aggression is the idea that, you're really going to want to go and fight a bunch of enemies. Throw caution to the wind. You don't care about picking up health potions or anything like that, really. You want to go fight enemies, and maybe you want to go to any kind of hazards or traps in the level and prove yourself by disarming them or kind of, getting past those environmental hazards and that sort of thing. So let's ratchet that up too so that we get someone that really wants to go for enemies. Adrenaline is the type of person who maybe wants to go for enemies a little bit, but kind of likes that vertigo-based play. For those of you that might be familiar with Calwa or the like, people who want to kind of run to the edge of the level and they want to flirt with the little hazards that are around. They want to peer over the edge of a gorge, that sort of thing. So let's just turn that down on our agent. Let's say they're really aggressive, but they don't necessarily want to go running up to poisonous mushrooms and the like. Caution. Let's turn that down so we get someone that really wants to fight all the goblins. Caution is kind of, the opposite. It's the type of player who's the survivalist. They're going to actively avoid hazards. They're going to actively look for items that can kind of preserve their character, health, ammo, and that sort of thing. And then we've got efficiency. And we're going to turn that down here because we don't want this agent to finish really quickly. We kind of want to watch them meander around the level. But this is kind of based on the idea that there's going to be a certain type of player who's maybe the speed runner, who's maybe the person that just wants to get through the game and see what happens rather than meandering around collecting absolutely everything. So an agent that was really efficient would kind of prioritize hitting mandatory objectives, hitting the exit, and just kind of completing the level, that final objective, rather than wandering around a lot. So basically the idea is that you could kind of customize this to be anything you wanted. We also have some profiles that are built into the framework. We're going to show you that you can kind of define your own later on as well, that you can use to assign values to the agent automatically based on a given profile. So if you wanted, you could create a profile that had kind of a range for each of these criteria that reflected your target market. And then just when you're setting up your agents, you select that profile. If you're testing one by one, you can randomize within those ranges. Or if you're testing a bunch of agents at once, you basically select that profile, say I want 50 agents, hit a button, go grab a coffee, and then when you come back, you'll have a recording of kind of where those agents went in your level. So let's have a look at kind of what the agents actually look like when you're running. We'll just let this go for a minute, and then I'll give a quick pause so I can kind of explain what's going on with the user interface. So we can kind of see this guy walking around here. Let's see where he's going. Oh, he's going straight for the crystal. I'm thinking he's probably going to hit up all of those enemies when he gets there too, since we set him pretty high on the aggression scale. So this agent's going immediately for those little crystal objectives that you kind of have to go to complete the level. And let's see, yeah, he's decided he's going to curve around, collect some things, fight some of the enemies, then go back there. Let's see where he's going now. Okay, now he's heading over to this little point of interest. Again, we're kind of seeing that high curiosity scale reflected, just trying to hit up absolutely everything in the level, kind of darting around, trying to see what all parts of the level are. So I'm going to pause this real quick, just so that I can show you guys kind of what happens in the user interface here. So what's going on? Well, obviously we can see the agent here. He's got that little camera. That's the player's viewpoint camera. You can position that on the agent kind of depending on what perspective your player has. If it's a third-person camera, you can kind of click it up behind the agent, what have you. And the way it is in this game, we're assuming it's first person, so it's just kind of locked at the front of the agent. A copy of that camera will be rendered on the lower right so you can see exactly what the agent sees. And then in the lower left, you have, this is actually a graphical representation of the agent's mental map. So I talked about the fact that agents have a memory system. That memory not only tracks those interactive objects that you've specified, but it also builds a mental map of the level's geometry. And this is kind of like the nav mesh, except it's a representation inside the agent. It doesn't just kind of copy the nav mesh to the agent and say, you know, here's the obstacles, here's the traversable terrain, because that would be a perfect information scenario. And if you're dealing with real playtesters, it's not a perfect information scenario. You know, they see the level as they move through it. So what you have here is that these little black tiles kind of represent what's unknown to the agent. You'll notice there's a little slice out of the lower left corner, and in that case, if we kind of go back and look here, you'll recall the agent started around here and just set off directly in a straight line. So the agent never saw this part of the map, so it has no idea what's there. The blue parts in the map indicate clear terrain. So when the agent kind of casts out rays to approximate players' vision, it'll kind of detect and see if there's any colliders in the way. If not, it'll continue to cast and say, you know what, this is clear terrain, I could potentially walk here. As the agent walks around the map, it'll kind of fill in where it's been. That's the little green tiles that you can see. And while it's looking around or while it's moving around, if its eyes or its, you know, feet while it's actually moving around run into a collider, it'll mark that as an obstacle. And the reason why the agent keeps this mental map is not just to give you as a designer an indication of what the players have seen and where they can go. It's also worked into the agent's pathfinding. So on a moment-to-moment basis for just walking across a short distance, we fall back on Unity's nav mesh. We're not really concerned with the physics of how the agent's going to move across the ground. You know, it's the equivalent of the player holding forward, not really a crucial part of the experience that we're looking at testing. But kind of when you're looking at those longer treks, the agent actually has this non-deterministic pathfinding that operates on its mental representation. And why this is important is this is affected by the agent's characteristics. So if I give you an example, an aggressive agent, for instance, will remember where enemies and hazards are on the map, assuming that it's, you know, seen them so that it knows that they're there. It'll project that back onto this mental map, and then it'll kind of mark that area as hazardous. And if the agent's really aggressive as it's wayfinding back through this mental map, it'll prioritize going through that area. Kind of the idea being that if you had a player that was trekking across the map to go to an objective, if they're really aggressive and they see a camp of enemies, they're going to swerve towards it and go to fight them. Likewise, if they're cautious, they're going to swerve around that, try to avoid being seen, try to avoid a fight. And that's what we try to mimic here. So the agent's wayfinding doesn't just happen on the navigation mesh. It also happens on this mental map. So it's kind of a twofold purpose. It shows you as the designer kind of what players have seen and where they can go. And it's also used by the agent to assist in the wayfinding process. This other little legend up here that you can see is these little gizmos that get drawn on screen. So this is using Unity's gizmo system. You can toggle them off on the script if you don't want to see them, but they kind of provide information about those entities in the level that you marked as interactive. So you can see right now the little X means the agent's visited a particular entity. In that case, the agent won't go back to it again. It treats it as, you know, if you were simulating the gameplay interactions, the fight would have been had, or the trap would have been kind of diffused, or the POI would have been seen. You know, nothing more to see there. It's not going to factor into future decisions. When you see the little eyeball icon, I'm just going to unpause this real quick so I can move around a bit. The little eyeball icon is used for entities that haven't been visited that are in the agent's field of view. And the way this is determined is interfacing with Unity's physics system. It incorporates information about, you know, nearby colliders, what the apparent size of an entity would be on screen. And this can kind of tell you, you know, if you're wondering why a player is not going to a particular object, if you're wondering why isn't the player interested in this, you can kind of use this to see, well, can they even see that from their vantage point? And then kind of cross-check with the little map you have here. So if you have a level that's got kind of a lot of occluding geometry and things like that, you're noticing that players are maybe having trouble reaching objectives, you can kind of use this to debug that, if you will, from an experience standpoint. So if the AI agents are avoiding a corner of the level and you're going, why, there's so much stuff to do there, when you review this, you can kind of see, well, that's not visible enough. You know, the average player isn't going to see that because it's too small or it's not viewable from this angle that you're kind of guiding them on. And you can kind of use that information to shape how you're going to adjust the level. The little brain icon is something that the agent can't currently see, but that it remembers. So the idea here being that, you know, if this little goblin here is obscured by the campfire in front of it or it's angled behind a tree, or it's too small. The agent can't see it right now, but that indicates that the agent's seen it before and it remembers it. Things can kind of fall in and out of the agent's memory depending on how long the agent's seen it for, how many times it's seen it for, and that's again just kind of based on the literature surrounding human cognition, the idea that, you know, if a player sees something once really quickly, it's going to enter their visual short-term memory and then it's going to leave. They're not going to retain that information for very long. But if they walk by something over and over again, they're going to remember it. And if they set something as a goal, they're going to remember it. So we try to approximate that just to account for, you know, why players might forget what they were doing and then lose track of an objective. They might kind of get turned around or lost because they can't remember where key objects were because they only saw them once or twice and that sort of thing. Thank you for that, Josh. The little target icon, I guess I probably should have said this first, that's where the agent's currently headed. Agents will typically head for an interactive entity if they can see one. However, agents can also have exploration targets. So if an agent isn't really interested in any of the entities that it knows about, it might just decide to head for a corner of the map it hasn't seen and see what's there. And that's obviously more likely to happen if it's a curious agent. I say more likely because there is a measure of stochasticity we've added in. The way the agent scores objectives, it outputs a numeric score. That kind of almost goes through a fuzzification process in that if two objectives are really similar in score, the idea being that if a human player thinks two things are nearly equal, it's going to be a bit of a toss-up between them, so we inject a little bit of randomness into what the agent's going to do in that sort of case. You might also see the target appearing close to an entity. The reason that can happen is we deliberately inject a bit of error into how agents remember the position of objects if they can't see them. So here I'm targeting this little goblin guy here, but the target isn't exactly on the goblin because the agent knows approximately where it is, but can't remember exactly where. And this again is also to kind of help mimic that fact that players aren't always going to know exactly where they're going if they're trying to go back to something they've seen before. They don't know exactly where it is. So we just kind of got all these little things that are injected into the system to try and, I mean, to put it inelegantly, the original idea I pitched to Pejman for this purpose was to make AI stupid on purpose so that it would play a bit more like a human player, and kind of that's what we've done here. So if I just unpause this again, kind of when you're moving around, there's this camera that you can watch the agents move around. If I had a lot of agents moving around right now, I could kind of see all of them, and you can click between them to see what individual agents are doing at any given point. So that's kind of how the runtime works for individual agents. I'm just going to go through, before we wrap up the demo, a couple of the extra features we have in. Not gonna go through each of them in detail because they're a little bit more complicated, but just kind of some of those faculties that make this easier to work with in an actual design context. So here I've got the little batching window. This is the idea that you could run multiple agents at once, so you can kind of mimic the idea of having a larger scale playtest. Again, the idea here isn't to replace a playtest. We're not claiming that we're going to be able to perfectly mimic human navigation. It's just that you could get really quickly a coarse approximation of where people are going to go, so you can make some tweaks or maybe compare a couple of different alternatives before you spend all that money to bring in actual playtesters, spend all that time to see where they go, only to find out that maybe, oh, well, there's this big part of the level that most players aren't going to see because it's not on that golden path that maybe you could have caught if you had used a tool like this beforehand. So the idea here, you can specify any number of agents that you want to simulate. You can either simulate them in turn, or they can all go on the map at once. There's a soft cap. It's 8 at a time for agents that are on the map at once. And then anything above that, if you simulate them simultaneously, it'll just batch them individually in groups of 8. So basically, once you hit the start button here, all bets are off, all the agents go. You can enable a recording feature in the manager that'll log those agent traces for later, and I'll show you how you can review those in a second. But there's a couple different specifications you can use here to customize them. You can set your own ranges for each of the heuristics that define your agents. You can pick from a particular profile, and you can kind of see that'll auto adjust those ranges, or you can just kind of start with one of those and then customize it afterwards. You can have fixed values, so simulate a bunch of agents with the exact same profile. Again, they won't do the absolute exact same thing because of that stochasticity we've introduced, but if you have a really specific profile that you wanted to simulate, or you wanted to see what, in theory, a player with no motivation or kind of full motivation on everything would do, you can kind of use this for that. You can also import a CSV file with just kind of a list of player profiles with values for each of those heuristics. So just kind of open to whatever you as the designers what you want to do. Oh, good question, Josh. That's kind of for a future work portion that we've left. We'd be looking at the idea if you had real human players, you'd basically give them a questionnaire, you know, beforehand that kind of mimicked each of these motives. If you wanted to do that, you'd probably want to mix something like the Brain Hex questionnaire that it's from Nake and Bateman that has a lot of similar motives to this. And then kind of based on those players in your database, you could kind of use this to mimic those. So there's not a nice way integrated with human players in the tool for that right now to track their actual behavior and then export that profile. But that is something that we'd be looking at integrating into the system in our future work. But that's a good question.
You want to run it on a batch? I think it's interesting.
Okay, I guess I can show this right now. So I'll just set this up to 8. And let's say we'll go Explorers, hope for no demo syndrome. It'll just take a second to set up here. Okay, there we go. So I have a time factor set up now so that you'll see them kind of moving around really fast. But this is 8 agents moving at once. If I select any one of them, I can see kind of what it's doing. If I flip to a different one, it'll show that agent, what's going on in its head. And then you can impose a time limit from the manager on how long you want the agents to simulate, or you can kind of have them automatically turn off after they reach the final goal. I'll just stop this right now so that it's not really distracting. But that's kind of how the batch simulation works. Oh, extrapolating from actual play. Yeah, that again, that's entirely future work. We don't have anything in here for that right now. In theory, however, with the way the system is set up, the agent does connect each of those motives that we talked about to individual entities. So if you want to do something like that for this, what you would basically want to do is as hooks in kind of your code for whatever your real player object is, you would look at which entities the player is visiting. You would look into, I'll just show you this real quick. This little matrix that we have here that you can see for each of the motives has different hooks to each of the entity types. You would basically use the kind of transpose of this to say this player went to these entities and therefore has high values on this axis and this axis. It would be a relatively straightforward extension to the framework, but it is not natively included in the current prototype. But that is a really great feature, though. That's something that we would obviously hope to have in the final version. Okay, so the other tool that I want to show just before we talk about the visualization is the idea of creating agent profiles. So you can actually import and export sets of profiles between projects as well. But the idea here being that you can say, add a new profile. Let's call this profile Pejman. Pejman, how experienced would you say you are playing video games? Okay, I'm gonna say Pejman's far from a noob, but you know Pejman's a hard worker, so he doesn't play games too much. So he's maybe in kind of the 75th percentile or so. Pejman's a really curious guy, so I'm just gonna turn that range up pretty high. He's definitely a big achiever. He's actually the associate dean here in our program. So you know what? Let's just set that to 1 completely. Completionist. Pejman's always at least like a 95% kind of guy. I feel like he's not going to obsess over the last detail if it's going to get in the way of his work. But aggression, I don't think I've ever seen Pejman frown in my life. So we're going to go ahead and turn that down. Adrenaline. I feel like Pejman's not that much of a thrill seeker, but he's open to new experiences. So we're going to put that around the middle. Caution. Again, I'm going to put that around the middle. Efficiency. Pejman's a pretty efficient guy. I'm going to turn that up. Maybe slightly down from the top. You might get distracted by needing a coffee or something. So we apply that. We can now see that we have this Pejman profile. So if I go back to the agent here and I make this agent Pejman and hit apply, you can see that these sliders will kind of shift around in those ranges that we defined. Obviously always keeping achievement at 1 because again Pejman is the consummate overachiever. So that's basically how the profile works. Thanks, Veronica. So if we ran this now, we would kind of see that little Pejman behavior. But just to wrap up so that we have a bit more time for a Q&A, I'm going to show you guys the visualization system really quick. So obviously when you're going through an agent's behavior, you don't want to sit down and watch 50 agents at once. you want to record them and then kind of look at their behavior, and then if you have questions, maybe you rerun one of those agents and kind of watch the play-by-play, see what's visible as you're going along, that sort of thing. So if I go here, we have some logs pre-recorded by the lovely Atia for some different profiles. So let's have a look at some achiever agents. And if I just turn this on and add these files, you can kind of see that a heat map will be auto-generated, and this heat map will automatically be resized. The texture and everything will get generated for whatever level you have this in. And this just kind of gives you an indication of where the agents went. You can customize things like, you know, how big the tiles are that you're going to be displaying and that sort of thing. And this can kind of give you some questions about, you know, why weren't these agents maybe going over here? The question, having recorded these logs, and if you look at this, is that we only simulated the agents for about 2 minutes. So none of them had time to, quote unquote, finish the level. Being achievement type agents, they were busy collecting objects and such, so they never went to the exit because they just didn't have time. You can look at individual agent traces, so you can kind of see all of them. You can maybe go through and just review the trace of one individual agent. You can slice a time window and say, you know, where did this agent go in the first 30 seconds? What was his path? And that sort of thing. And you can also review what individual agent profiles were. So in this case, I'm going, okay, what was this agent? Well, if I look at this agent, he's got a pretty high achievement value, pretty high completion value. So it looks like maybe he was starting to, he or she, I guess, I like to personify AI agents, was kind of going on a zigzag through the level to maybe collect everything. And based on these questions you have, you know, this data is all in the log for that player. You can copy this into a CSV file, load it into that batching window, and then kind of replay that agent and see where that agent would go. You can also look at that level of engagement that I was talking about for different entities. So if I tick this little box here, this will kind of show what the interaction rate of engagement was in different parts of the level. So you can kind of set your own color scale here to see how you want it to be visualized. So in this case, if I'm looking here, you can see that there was a lot of activity around this crystal here, these kind of optional objectives. A lot of these collectibles were picked up. Not a ton of activity around the enemies around here. The agents didn't really care. They were just kind of going for these crystals. And then if we go to those individual agents and kind of look at their profiles, you know, it makes sense. We have pretty low values of aggression, adrenaline. If I look at each of these agents, they're not super interested in combat. So you can kind of use this to answer those questions. And if anything doesn't make sense based on the design of your level, you can kind of go through, rewatch those agents with those profiles, see what they're doing, and then understand why that's the case and kind of use that to make adjustments. So that's kind of it for the demo of the framework, just kind of start to finish, how you go about setting up the level, setting up your agents, watching them in real time, maybe batching them, recording logs, and then reviewing those. And then obviously you could use this to iterate on your level designs and so on and so forth. So I'm just going to pop back to the slides here for a moment before we get to the Q&A. So what are our next steps with this project? Well, obviously we're going to be looking at putting in more features akin to kind of what Josh suggested. That's a great idea there. We also want to look at, you know, collaborating with maybe commercial projects, integrating machine learning so that the agents can actually learn from human play traces and have kind of that option to learn a profile as opposed to just having that kind of expert-based estimation of what your target is. If you're curious about this project, if you want to learn more, there's going to be a title card at the end with all of our contact information. If you want to collaborate with the university, you know, in academia, we love industry collaborations, so feel free to reach out. If you want to help with the project at all, we're looking for people to help us test it and that sort of thing. If you want to try out the project, it's on GitHub. It's open source. All you need is Unity. There's a URL down there. It's also in the description on this stream. So you can kind of check that out, clone it if you want, check out the project. And if you are interested in getting your hands on the framework and kind of learning a bit more, of course, we would love for you to participate in our study. If you're interested in participating in research regarding the usability and usefulness of this tool, we're conducting a study at the University Ontario Tech where you would use the tool, and then we basically conduct an interview either in person or online about your impressions of the tool and how it might be able to support your project specifically. The study would consist of 2 sessions, either in person or online, as well as kind of an at-home exercise where you take the framework home and kind of play with it and design some levels with it. Participants do receive $50 compensation for attending each session. If you're interested in participating in the study, or if you want to know more, please contact us. There's going to be some information up on the title card at the end, and you can check the description for the repo, as I said before. So if you want to contact us, if you want to learn more about the framework, if you'd like to participate in our study, if you just want to chat about user research stuff, this is our contact information up on screen right now. And we're going to be sticking around for the next 10 minutes just on the stream. If you guys want to chat, if you want to post any questions in chat. Yeah, and Pejman, I think, is monitoring our Twitter account as well. Though it's probably just easier to go in the chat. So I guess without further ado, I guess I'll just leave that contact card up. Thank you so much for joining us, everybody. It was great to have you here. And I guess we hope to hear from you soon if you guys want to learn more about the framework or if you guys would like to collaborate with the university. Okay, so is this the part where we drop to informal now? We wait for some chat questions. We talk about coffee and cookies and Pejman's second cup or Tim Hortons?
Second cup, always.
Okay. It's maybe a bit controversial for our Canadian viewers. I feel like we might lose a few people with that.
Maybe just a few.
I feel like I can lose a lot of people if I'm just honest and say that I don't really drink coffee. I'm a tea person and a hot chocolate person. Though I do have espresso sometimes. Yeah, thanks for joining us.
Thanks, guys.
Thank you.
And again, the whole session is recorded, so
Yes,
we're going to share the
there
recording.
will be a recording of this. I think it's going to be automatically made public on YouTube. It's going to include that about an hour of dead space we had at the beginning when we were testing our encoder. So I'm going to upload a trimmed version of that as well that will be public on the channel for anyone that wants to watch this afterwards. Second cup or Starbucks?
It's still second cup.
Okay, so second cup's just your place. Have you ever been to Baker's Table?
Oh, I actually prefer
I haven't
this.
heard of that one.
It's an independent cafe in Oshawa.
Okay.
I
So
think
the
there's
question
this
about
Italian
audio,
family that owns it.
did you consider audio?
Audio for game audio as a form of feedback to the player. We do not. That's an excellent point. I think that would come in more if we were kind of simulating actual kind of gameplay mechanics rather than just navigation. Maybe this is just coming from a position of somewhat ignorance, not being an audio designer myself, but I feel like audio feedback is something that's really more important in terms of gameplay, unless you're playing a game where kind of the mechanics specifically revolve around audio having a role in navigation. I guess if you were using audio as a cue to let players know that there's an enemy around the corner, that would obviously be important. That's a good idea for an extension, but it's not something we're really considering right now, no. But that's again another excellent point. Agency, okay. Doesn't also mean- Right. Okay. So really, the idea here is that we're mimicking player intention. Obviously, we are at the point, Morgan, as you said, where AI doesn't really want anything. We're just kind of giving it rules and telling it what to do. But yeah, the idea here is that obviously we know that human beings, human playtesters, even if you're telling them, play through this level and you have this loose objective, they have free will. They can do whatever they want in the game, and kind of what they do is based not only on what you tell them they maybe should be doing, but what they're interested in as a player. So here we've kind of tried to mimic that with the idea that, that some of that markup that I was showing, you can specify whether objectives in particular are mandatory or optional. So the idea being, if you were kind of testing out where players are going to go if they have objectives in a game that they must complete to clear a level, you can tag those with that little mandatory objective marker, and the agent knows that it cannot reach the end of the level until it goes to those objectives. So that kind of gives you that idea that you're going to be telling playtesters that they have to do the mandatory missions or whatever. Like if you're playing this game, obviously the implication is that you're trying to finish this game. So that's kind of what we've done here to try and mimic that. I hope that answers your question, Morgan. I'm not sure if that's exactly what you were getting at, but the idea is that we're kind of trying to mimic that inherent blend that there is in games of the game telling you to do something, but you also having the free will to kind of act how you want and have the freedom within that restricted system. So that idea of play motivation kind of being forked like that. Yeah, that's a good point. Okay, so on to Veronica's question about multiplayer. Right now, we are looking at single player. The agents are intentionally ignoring each other. So they basically have colliders on them that say, ignore everything. The agents aren't going to be running into each other, and the agents do not have a shared pool of, we interacted with this or one of us defeated this. However, the way the system is set up, it would be fairly straightforward to do so. Essentially, the agent's components are modular. The site, the memory, and the goal finding are all independent on each agent. What you could do to kind of support multiplayer, this wouldn't really work out of the box with the code that we have. Again, it would be a quick back-end modification, more or less, to say that the agents would share a memory. So if you were looking at something like co-op multiplayer, you would basically say, that they share a memory together, so mimicking comms between teammates and saying, one of us defeated this enemy, so we're not worried about that anymore, it's dead to everybody. So the system would support it with minor modifications, but it's not in the current prototype out of the box. Morgan's question, getting qualitative data from the bots. That's an interesting question. So yeah, exactly. So pure qualitative data, no. Fuzzified numerical data that kind of gives the impression of a player saying, I liked X area because, yes. Oh, message retracted. I do think that's an interesting point, though, because if we look at HomeGuard's work, which was one of the projects that Atia mentioned early on, they kind of had this system where the personas would rate a level based on how much those individual personas had to do. So Monster Killer could effectively say something like, I like this level because there were a lot of monsters to kill in this level of the dungeon crawler that they were working with. So in the sense that you can kind of take, the things that the AI does and then apply a very basic system that kind of interprets that to give an overall impression, it's possible to approximate the kind of qualitative feedback you might get from players. But with this system, with what we're looking at, getting that kind of the same exact thought process you get from a human, I think you're looking at a system that's far more advanced in terms of maybe it's using computer vision to interpret the level, and then it's got some kind of reinforcement learning engine that's based on real player data to go through and see what players do, and then maybe taking, say, interview transcripts from players, applying semantic analysis to that, cross-referencing it with what those players do in the level, and then kind of based on what the AI does, it learns from how players react in interviews based on what they did, and then based on what it did, it tries to then, respond to interview questions following the same patterns that humans players would. Off the top of my head, that's how something like that could work. It's not something that we're really concerned with in this system. Time information, yes, excellent point, Simone. That is something we have to a limited extent to say we have those kind of time windows, so you can kind of slice, what agents did in the first whatever interval of gameplay, and then say, were most agents interacting with this entity in the last part of their gameplay? Were they interacting with it at the beginning? Can I just view the trace of this agent between, these timestamps? Obviously, ideally, in the future of the visualization system, we would display that in a more elegant way. So something like, mousing over the pathway of an agent to say, this is kind of the timestamp, this is the order these objectives were visited in, that's kind of marked in an ordinal way, looking at different formats for display, kind of just making that visualization tool a bit more robust so that it's easier to reason with huge collection of agents that maybe played for a really long time. But yeah, that's a great point. That's something we have a kind of rudimentary form of. It's something that we'd be looking at making even better as we kind of move on with the framework. The audience is smart. They're putting in questions in the chat so that we don't have more coffee banter. Or, Earl Grey banter in my case.
think there's no more
Yeah.
question
Okay.
from-
So I think we're probably good, and it is almost 3 o'clock, so we're probably gonna be saying goodbye. Thank you everyone again so much for coming. Thanks for the great questions, the kind words, and we would love to hear from you guys for any future discussions. Again, if you're interested in participating in our study or collaborating with the university on a project of your own, we do a lot of industry collaborations. We love doing that here. Pejman especially is kind of the industry guy here in the game dev program. I don't think that's an overstatement. So yeah, we'd love to hear from you, and thank you so much for joining us. So bye everybody,
Bye.
and we will see you later.